Am I audible to all of you now? Good afternoon, all of you. Online, offline. Audible? Is the screen fine? Is the screen fine? Yes. Hi, Aman. Okay, fine. So all of you, good afternoon. I think you all have logged in. So we have Charu. The video is buffering. Is it just Charu or others also same problem? No? So that's your local server in that case, or your local connectivity then. For the rest is fine. Same problem, Leela. Screen is not full size. Why do you say so? Screen is fine, right? All fine? So some adjustments you must do from your side. Okay, maybe double click the screen, it'll open up. It's full size from my side. Okay, Jay, but don't do that every day because we'll switch from here then. Okay, Ayman. Subduction, yes. The earthquake along American boundaries because of subduction of the Pacific under the North American. Okay, let's start off now. So we finished off for the older batch. So in the class, we have some new students who have joined us from climatology. So all of you are part of the cycles there. Okay, when topic gets over and there's not much of link beforehand, we have these new additions here. So those who are joining from today, we are beginning climatology, and geomorphology will be done in the cycle subsequently. And yesterday we finished off geomorphology. So we maintain this pattern, okay? Right now, these classes are the foundation classes. Okay, my focus here is cover the syllabus. My objective is 95% of coverage here. And there'll be some small topics, which I suggest if we have time or quick reading on your own, shouldn't be a problem. And the advanced concepts we'll take up when we take up the enrichment classes. Some of you are asking me about arid cycle, cast cycle. Those are not the regular questions that we have in your foundation classes. The foundation, I think we are done. Ab jo add karna hoga, and I told you a couple of links also on YouTube. Go back and have a look. The arid cycle I have discussed. Appalachian Mountains origin I have discussed. So some of what I can put, I put it on the YouTube. You can have a look there if you are curious there. For others, don't bother what has been covered. We start off today. The unit is climatology. Climatology. This is the second unit of paper 1. And the longest unit is geomorphology. It takes good about almost 25 odd days. Okay, is geomorphology. And thereafter, the topics are relatively smaller, 10 days, 5 days, and so on. So I know students, when I'm not teaching geomorphology, har din request aayega, sir, kab shuru kar rahe hain? Geography. As if the rest is not geography, only landform is geography. And when I start geomorphology, the question is, sir, kab khatam hoga, bata do geomorphology. Okay. So it's like, you assume that all topics have equal weightage. It's not like that. Some topics will take more time, and geomorphology does take more time. Okay, so that's fine. So this is the next topic, climatology. Your reference book is climatology by Savindra Singh. There are other books also. There's one book by D.S. Lal also, but I will not recommend this because D.S. Lal doesn't cover the important topics as in your syllabus for UPSC. Okay. Yes, Nikita. Okay, we manage, we live with all of them. Okay. Hi, Akash. Okay. Yesterday we had somebody on the, on the YouTube. His name was Vitamin Proteins. Okay. And today we have somebody called Mr. Blank. Okay. Mr. Blank, you sound like a scientist, by the way. Blank and Blank's theory types. We know Planck's theory. Oh, yes, Arya, of course. All of you happy Onam. Yes, today is Onam and a pretty big one down south. Okay, here are the other versions. Yes, so my wishes to all of you out there and online also. Happy to be back in live class. Kyun, kahan the abhi tak? You were doing recording sessions, Manasa. We have been live. I do not have recordings. Okay, you have other classes. Chitranshu. Oh, you are the person. Okay, fine, fine. Whatever lag, I think it is largely your local network. Okay, so maybe buffering, you can switch off and switch on or boot in again, it will work. Come back here. D.S. Lal is not the recommended book from my side because the syllabus is a bit more expansive and this book doesn't have all the topics. So I'll remain with Savindra Singh and I'll suggest all of you at your convenience. I mean, do not be, let not be a mad rush. Please look into NCRTs. Okay, at least look into NCRTs of class 11th, physicals of the principles of general geography. So look that up, please. Again, NCRT and shouldn't be difficult to understand. But anyways, I will be doing your topics as a part of optional. Yes. Okay, we'll start off here. These two topics have questions every year. One is geomorphology, they ask questions every year, and this topic from climatology. Baki topics that keep on mixing. Sometimes they do ask, sometimes they don't ask. But these two topics will definitely have one question. At least 15-20 mark ka question hoga aapka from these two topics. So you can't ignore it. Okay? Let's start with climatology. The first is discuss atmosphere. So those who have joined me fresh today, you have to listen to me and don't wait for me to tell you right. Okay. In the classes, I'll be speaking spontaneously. I will dictate some deliberately, but whether I say or not, your notes must go on. Whether I declare it or not, you must be writing your notes. Okay. So don't wait for me to announce that right. Okay. And if you miss something, be patient. I repeat whatever I teach you. And whatever I say, I try writing also. Okay. So most of you are confused ki writing hai bhi ki nahi hai. Ki writing hi hai. Okay. So don't doubt that part. But the importance is why I write is to maintain a speed in teaching. So when you make notes, don't look at the board and make notes. You make notes listening to me. And you have a doubt and clarify. Okay. Then look at the board and try making sense of what I wrote. Okay. But if you look at the board and write, you can't write then. In fact, that's the wrong method of any notes making, whether I write or don't write. Okay? So be alert. Be attentive, you learn. Eventually you get used to the methods we teachers have. Okay. So atmosphere. The first discussion is that atmosphere is an integral part of our Earth. So when we say Earth, I don't mean Earth in terms of solid land and water alone. We also include atmosphere as part of Earth. Atmosphere is an integral part of Earth. That's why a lot of books mention Earth as Earth atmosphere system bolte hain. Okay, we talk about Earth as Earth atmosphere system. So do not see atmosphere as a separate entity. It's very much part of our Earth. That's first point. The second point is, now the origin of the atmosphere has been an evolutionary process. It's not a one event, okay, origin. Our origin of Earth has also been a sequence of events. What Earth was 5 billion years ago, 4 billion years ago, 2 billion years ago, it has been different. And what we have today is much, much different. The older Earth was probably mass of gases, mass of plasma, mass of molten rocks. Slowly, gradually, it has changed into whatever we have as continents, land, and so on. So I say the atmosphere that we have today, okay, the origin of atmosphere, okay, is part of the evolution of Earth itself. Just as Earth has evolved, Earth has changed, so also the atmosphere has evolved and the atmosphere has changed. So the atmosphere ka jo origin hai, the origin is from the interiors of Earth. So there have been two versions. One version says the gases of the Earth are probably from the outer space. The space has some gases, and Earth's gravity probably pulled those gases towards itself. That's one version. But now we say, no, that's not right. So if this is the Earth here, and it's outer space has something, some gas, some type of electrons, there are certain unknown particles, again, Earth's gravity pulls them. Earth's gravity pulls it towards itself. So some thought the atmosphere was because of that. But now we say, no, the atmosphere is not from outer space. It's essentially from the interiors of Earth itself. Okay, so atmosphere origin is not from the outer space, exterior nahi hai, it is from the interiors of Earth itself. And we can broadly say that there have been two major phases, or I will say three major phases in atmosphere's origin. When the atmosphere was originating, okay, it has been the consequence of three important phases. One important phase was when Earth was accreting. Earth was accreting means Earth was forming. Earth was accreting from the ancient nebula. You understand what nebula is? I think some of you have read that with me. Nebula is an ancient mass of gas, dust, and clouds. A nebula is a gaseous body. It's a primordial, very, very old, ancient, billions of years old. Okay, it is an ancient cloud. And this cloud, for some reasons, starts to condense, starts to come closer. It starts to accrete. Okay, and the heavier particles will go inside. They become the core. The lighter ones will stay outside. So imagine this is the nebula. Okay, massive amount of gases, a lot of which you do not know also. There are dust particles, and this will start cooling, contracting. So this nebula starts to cool, it starts to contract, it starts to solidify. When it does this, it is a principle where the denser ones will become the central part. Okay, and outside, the layers will have less density minerals. That's how the core has become very dense, and you go outside, it becomes less dense. And the lightest ones, which were gases, they became the outermost layers. That's why I'm saying atmosphere is very much part of Earth itself. Okay, so in the first phase, I said, Earth was accreting. Earth was forming from some ancient nebula. The gases the gases where the lightest matter, and those gases formed the outer layers of Earth. So when nebular accretion happens, when the nebular formation happens, okay, into a planet, जो कुछ भी dense है, very, very heavy dense, it will go inside. Okay, there's something called as, I think I've used the term earlier, something called as a gravity collapse. In the gravity collapse, whatever is dense will go inside, and whatever is lighter, halka hai, it will stay outside. Okay, that's how it forms. So in this process, the lightest ones were gases, and the gases stayed outside. So imagine our Earth here, this Earth, the dense iron, the dense nickel, the magnesium one stay inside, the lighter aluminium, the lighter silicon will stay outside, and the gases are outside. And these gases, the initial ones were largely hydrogen and helium gases. Okay, the first gases that formed the atmosphere were largely, the gases that formed the atmosphere were largely hydrogen and helium gases. Were hydrogen and helium gases. They formed the outer layers of our Earth. But hydrogen and helium were very, very light, बहुत हल्के थे, and they would escape. Okay, so in this phase, what happened was, okay, these gases were largely a hydrogen gas and helium gas. They were very, very light, and they escaped Earth's gravity force. They were very light and escaped Earth's gravitational force. Okay, so this was one phase in Earth's atmospheric origin. This atmosphere has gone. Then we had a second phase of Earth's degassing process. The second phase was the process of Earth's degassing. Degassing as in the volcanic eruptions. The gas is coming out from inside. This is the volcanic eruptions. And overall, the billions of years of Earth's formation, Earth has had volcanoes. Okay, the degassing process. Okay, this created nitrogen gases. This created carbon dioxide. This gave us the hydrogen gases, water vapor. It gave us a lot of other nitrogen compounds. It gave us sulfur compounds and so on. The degassing process gave us, I said, nitrogen, carbon dioxide. It gave us nitrogen compounds. We call them as NOx, like NO2, N2, and all of that. They gave us sulfur compounds and water. Okay. Now what happened was, this atmosphere did not have oxygen. It was largely an atmosphere without oxygen. But then what happened was, this water vapor that we got from volcanic eruptions, this condenses and falls down as rain. Okay, so water vapor, okay, fell as rain. Okay, and this became the waters of the oceans. This became the water of the oceans. Okay, and a lot of carbon dioxide, this got dissolved in the water and is now largely in the oceans. The initial atmosphere had nitrogen, carbon dioxide, water, and the rest. Water condensed and fell down as rain, and that is what became the water of the oceans. The oceans' water are from this atmospheric water vapor. And the carbon dioxide that got dissolved in the water, and it's now present inside the oceans of the Earth. Oceans have a lot of carbon dioxide. That's why we say, if the ocean starts becoming more and more warmer, the carbon dioxide will release further. It'll only increase the global warming even more. Okay, so water becomes the ocean waters, and the carbon dioxide has now been dissolved in the water. This was one phase. And then the third phase was the emergence of life on Earth. And with life on Earth, with plants on Earth, okay, with certain type of bacteria on Earth, they are responsible for the creation of oxygen gases. The oxygen gas is the consequence of the biological process, okay, in life and its evolution. The emergence of life on Earth, okay, plants and bacteria, they gave us oxygen. Okay, so we have this photosynthesis, okay, some chemosynthesis, chemical reactions, and photosynthesis, the light reactions in the plants. This forms the oxygen of the atmosphere. Yes, I can understand. Akshay, Sneha says, you are new kids on the block. Ladte raho. Okay, you will understand, how to take notes eventually. Okay, so no worries. Okay, you write on whatever you can. Okay, so this is not an answer. This is not even geography optional. This is called as trivia. Ye GK chal raha hai abhi aapka. So GK mein one word will do. No one will ask you on 60 words mein likho the origin of Earth's atmosphere. How it is formed, Raju, just remember degassing process. That's all. What chemical reactions? Okay, we will not bother about it. But then, of course, we have the process of nitrogen cycle that ultimately makes more of nitrogen. Okay, ye dekho, Arya. Okay, why is water salty? Salt hai isliye. Okay, if there's salt will be salty water. That's why. What's below photo? Photo ke niche frame hoga aur kya hoga beta? This is chemosynthesis. Chemosynthesis. Okay. So first phase, the gases are from the Earth's accretionary process. The second phase, we have the degassing process that gives us certain type of gases. And the third phase, we have the biological processes that create the oxygen. Essentially, the atmosphere is a product of a long history of atmospheric evolution and is the result of the product of long history of evolution process, a long history of atmosphere's evolution, and is the result of mechanical, chemical, and biological processes. The atmosphere is the result of mechanical, chemical, and biological processes. Okay, that's it. Just in quick short introduction, how was our atmosphere formed? Okay. If water dissolved in ocean, can we say acidic? Yes, it is, Madhav. Okay. If carbon dioxide is there, it is a slightly acidic water. pH is 7 neutral is only possible for distilled water, maybe. Ocean waters are definitely slightly acidic. Correct. Okay, let's move on. So that's origin, not much to remember here. So let's talk about the next discussion is the atmospheric composition. The atmospheric composition. What is the atmosphere made up of? How was atmosphere formed? The next conversation is what is the atmosphere made up of? It's made up of gases. It's made up of dust particles. It's made up of ice, crystals. It's made up of water vapor, and it is also made up of aerosols. Okay, the atmosphere has gases, the atmosphere has dust particles, the atmosphere has ice crystals. Ice crystals is not same as a snow, or ice. Special type of formations. They have some structure, they have some patterns. So ice crystals, water vapor is in the water vapor and moisture add kar do. some of it is gaseous, and some of it is liquid form, moisture, and aerosols. Anybody knows what are aerosols? AEROSOLs. What are aerosols? Dust particles. Aerosol essentially is a solution with air. Okay, any solid thing inside the air is called as aerosol. Okay, aero as in air, sol as in solution. So it's a solution where air is an important medium. In that we have some solids, correct? So some of us can mention dust particles are like aerosols. And by the way, please listen to this. All these 5 components are natural. Okay, don't call dust particles as pollutants. Don't call aerosols as pollutants. Not all of them. Anybody knows what is a pollutant? What's a pollutant? Impurities. अरे वही चीज आप उल्टा बोल दिया. What is an impurity? Yes, anything which is not supposed to be there, either in proportion ratio or in absolute terms. Okay, so dust particle, for example, I'm expecting 10 units of dust particle. If that 15 of them, then I say 10 is natural, 5 is pollutant. Okay, so something which is not supposed to be there in absolute terms or in relative terms or in proportion, it's a pollution. So don't call all of these as pollutants. There's some categories which are not supposed to be, like say carbon monoxide. Carbon monoxide is not natural. It's because of incomplete combustion of our fossil fuel. So carbon monoxide, pura ka pura, it is a pollutant. Whereas nitrogen compounds, not all of it are pollutants. But what we add unnaturally, that's a pollutant. So pollutant, when we say, most of us see dust as pollutant, not always. The atmosphere's natural composition is all of this. It has gases, it has dust particles, it has ice crystals, it also has aerosols, includes some dust particles. Even salt aerosols are part of the atmosphere in the lower layers, wherever we have some oceans or seas. Okay? That's the composite atmosphere. Now, in the composition, I'm talking about the gases. Okay. There are certain major gases, okay, and these major gases are kind of permanent, and there are certain minor ones, okay, and some of the minor ones are okay, you can say variable gases. Not all of them, some of them are variable gases. So atmosphere, the major gases may, we generally add nitrogen and we say oxygen. These two are the major ones. Nitrogen approximately about how much? Anybody knows? 78% is approximately nitrogen. Oxygen how much? 21% is oxygen. Yes. A percent in what terms? When you say percentage, it is by what? आगे बताओ, send parts पर एक तो आप percentage कह रहे हो, फिर parts पर कर रहे हो. By volume, something more of, by volume of, yes. So this is percentage by volume of dry air. Most of us miss out this point. In this percentage calculations, I'm ignoring water vapor. Okay, so nitrogen 78%. Yes, volume of dry air. Don't miss this point. In prelims, these are the words which will trap you. It's by volume of, okay, dry air. These are the major gases. So these together make up 99% of the atmosphere. These two gases. And minor mein, we have argon. Argon is 0.93% is argon. Carbon dioxide is 0.03% is carbon dioxide. We have got helium and ozone. It's a very small amount, 0.0005056.4%. Okay, is approximately helium and ozone. Okay, so if you add up, look at this. This is 99%, argon 93%. and this. So you can say 99.96% जो है, it is just 4 gases: nitrogen, oxygen, argon, and carbon dioxide. They make up 99.96% of atmosphere by volume of dry air. So these numbers you will remember, okay? You will have to know some of the facts, remember these facts. And water vapor हम अलग रखते हैं. Water vapor we say is a variable one. It's variable. So is dust. Particles are also variable ones. Okay. Some of us now books say that carbon dioxide is also variable. Why? Because of your global warming and because of emissions issues. Even carbon dioxide has now become variable. And the right amount of CO2 we should have, if I go by percentage, 0.03% by volume of dry air. This is approximately around 200, 250 parts, okay, ppm, parts per million. It should be this much amount of CO2. But in reality, today we have how much? It's more than 400. It's more than 450 ppm, parts per million. So carbon dioxide ultimately, because of human activities, deforestation, emissions, has increased. Okay, so some of them consider CO2 is also a type of a variable gas today. Apart from this, there are other gases also. We have also helium, we also have hydrogen, but they are very, very negligible. Let's ignore some of these gases for now. All done here? So what is major gas? What's the minor gas? What is the permanent gas? And what are the variable gases? Variable mein the most important variable gas is water vapor. Water vapor can vary 0 to 4%. 0 when the air is completely dry, and 4% when the air is completely saturated. Yes, Mohit, correct. 0 when air is dry, and when air is saturated, it has the amount of water vapor that it can hold in terms of the conditions natural. The maximum is 4% of gases will be water vapor. But then it's variable. It varies according to seasons, locations, elevations, it varies. Now, one important point in this conversation is that much of the atmospheric composition, does not play important role in climatic processes. Anybody understands this? Much of the atmospheric composition does not play any significant role in climatic processes. Much of atmosphere does not play a significant role in the climatic processes. Why? Anybody can tell me why? Yeah, go on. Very right. Yes, that's right. Yeah. Tropopause acts as a lid. Okay, fine. Anybody else? Ground नीचे homogeneous है, heterogeneous है. They don't impact pressure. So good, nice. Lot of facts, biological process. बेटा मैं बात कर रहा हूँ climate. आप बोल रहे biology. Okay. Anybody else? Yes, Uma Shankar, you are right. Okay, to some extent, Ashish, yes. Now see, बाकी सारा ठीक है. Theory, you know something, but you have got it absolutely wrong. So the answer is, देखो, atmospheric process means what? Atmospheric process means winds. Atmospheric processes means cloud formation. Atmospheric processes mean rainfall and precipitation, snowfall. Atmospheric processes का मतलब है there are seasons and temperature variations and so on. All the atmospheric processes are fundamentally about there is variations in the solar heat in the atmosphere. Some areas are warm, some areas are cold. Because it's warm, it will rise. It rises, condensation, clouds, and rainfall. Because it's warm, it rises. What is cold will move towards the warm. This becomes the wind formations. If it rises very fast and can become hailstones, it can become snowfall. So fundamentally, all climatic events are the consequence of differences in the solar energy in the atmosphere. Some are warm areas, some are cold areas, which means the climatic processes are the consequence of the ability of the atmosphere to absorb heat energy. Jahan par heat absorb hoga, the area becomes warm. They can't absorb, it becomes cold. So equator areas are warmer, the tropical areas are warmer, the polar regions are cooler, okay, and therefore the winds will start moving. Therefore, even the oceans will start moving in the form of ocean currents. The fundamental reason why we have atmospheric processes are, the atmospheric processes are part of a mechanism where the energy is getting redistributed. Okay, so Radhan's point here, that atmospheric processes are what? They are a set of mechanism. They're a set of mechanism that redistribute the solar energy. They redistribute the heat energy within the atmosphere. Okay, it is in this redistribution process that we will have winds, we will have clouds formations, we will have precipitation and rainfall, plus all of this can also drive the ocean currents. Okay? All atmospheric processes are essentially a set of mechanisms that redistribute the solar energy or the heat energy within the atmosphere. They redistribute the solar energy and the heat energy within atmosphere, and this redistribution is responsible for the winds, for the clouds, for the rains and precipitation, and they also impact ocean circulations and ocean currents, which means only those substances which are capable of absorbing heat energy from the sun, they will drive atmospheric processes. Okay, therefore atmospheric components that are capable of absorbing heat energy and the solar insolation energy will be responsible for the atmospheric functioning. Okay, it's a very elementary concept, but we tend to gloss over this. Okay, so atmospheric components, I repeat, atmospheric components that are capable of absorbing heat energy, atmospheric components capable of absorbing solar insolation, capable of absorbing a solar insolation, incoming solar radiation का short form है insolation, incoming solar radiation. Okay, so those components which can absorb heat energy, which can absorb solar insolation, they are responsible for the atmospheric functioning. Okay, so what happens is, in our atmosphere, nitrogen, oxygen, argon, and to this I can also add other gases like krypton and hydrogen rest. So this is 99.9% almost. Okay, 0.93%. These are not effective greenhouse substances. They are not good at absorbing heat energy. That's why these gases, they are not important for atmospheric processes. They are not good, efficient in absorbing heat energy. They are not efficient greenhouse substances. Anything which absorbs heat is called as greenhouse substance, heat as in solar radiation. So carbon dioxide and oxygen, nitrogen and argon. Argon is an inert gas. These three major ones, 99.93%, are not capable of absorbing heat energy. Therefore, they do not play an important role in the atmospheric processes, whereas We have gases like carbon dioxide, we have water vapor, moisture, even dust particles, even ozone. Ozone is 0.0005%, very small amount of ozone. And this is in totality, I mean, this is less than 0.1%. These gases are more important in the atmospheric processes. Okay. Akshay, that's a mistake you are doing. I told you, pehle se hi, don't look at the board and write. Listen to me and write down. It'll take you some time, don't worry. Okay. What about answer writing? What about Sudhanshu? Bolo? Aap padhana chah rahe hain answer writing? We can adopt you. Okay, fine. So Akshay, I repeat, all of you, you will not write looking at the board. You will write listening to me. And everything I'm repeating at least 2 or 3 times. Okay? So don't lose patience. You're lagging continuously. Don't worry. ऐसे ही मर पड़ के सीखते हैं सब कोई. You're beginners, accepted. Okay. But keep writing. Okay. So carbon dioxide, water vapor, I said why? Because it's variable hai, but it's a very, very important greenhouse gas. So our point here is the minor components and the variable components. The minor components and the variable components, this totality mein, they are less than 0.1%. They play a more important role. They play a more important role in the atmospheric phenomena. Okay, these are the greenhouse gases. These are the greenhouse gases, or call them as greenhouse substances, because in these components we also add dust particles, we also add aerosols, okay, we also add salt crystals, okay, we also add your ice crystals. Not all of them are gases. Right word will be that these are greenhouse substances. All good? Okay, so a discussion point we had about the atmosphere, and which, but remember, I'm not saying the others are not important. They're important, they have some other role to perform. They say if oxygen has no role to perform in atmospheric processes, hata do oxygen ko. Okay. So it's not like that. They are important, but important maybe for biological process. They're important for diluting the atmosphere. They may be important for absorbing some other type of radiations which are harmful for us. So it's not that important nahi hai. Okay, that's not my point. The nitrogen has a very important property or a role of diluting the atmosphere. Otherwise, atmosphere will start burning. Oxygen will support combustion. Okay, it will start burning. Oxygen is very important for your respiration. It is the life gas of our planet. Respiration important hai. So our point is, inka alag role hai, but when I talk in terms of a climatic process, I mean something different. The winds are climate. Okay, the rainfall is climate. The temperature variations are climate. Okay, the cloud formations are climate. In fact, we say the major elements. What are the elements of weather and climate? The elements of weather climate are, okay, precipitation and rain, humidity, we have winds, we have clouds, we have a temperature, and we have pressure. These are the elements of weather and climate. Precipitation and rains, then humidity, not same as rains. Humidity is moisture in the air. Clouds are a formation. Okay, winds is the air moving. Temperature is one of those physical properties of, okay, the atmosphere. And pressure. These are the 6 elements of weather climate. these 6 elements, they depend on these substances, which are greenhouse substances. All good? Okay, can I move on from here? Anand, you will learn that I very efficiently ignored some questions. Okay, so I said, you are free to ask questions to me, but you must allow me to choose what to answer. Okay, so your question is right. Okay, but right now I will not take it up. Okay, some other context we'll discuss. Can I move on? All good? Okay, fine. Let's move on. Now we'll talk about, so I have talked about origin of atmosphere. I talked about composition of atmosphere. Okay, the third thing I'm discussing is the structure and the organization of atmosphere. How is the atmosphere arranged? I'm discussing the arrangement and the organization. Kaise layers hain, how the mixing happens and so on. Okay? So I've done origin, I've done composition, and moving on towards the structure. Yes, absolutely. Our composition of atmosphere includes ions. But when I say ions, I essentially mean some form of the gas. The gas can be molecular, the gas can be atomic, or the gas can be ionic form. The form is different. Okay. Yeah, so composition gases, bolne se, it includes ions also. Okay, so yes, atmosphere includes ions. Fine, you can add that point here. Okay, the structure of our atmosphere. The first point is, okay, now this is an important discussion here. The first point here is that atmosphere is not a homogeneous body of air. The atmosphere is not completely homogeneous. It is not completely uniform in composition. Okay, that's one point. Second point is atmosphere is a mixture. It's a mixture. When I say mixture, ka matlab kya hai? It is a physical aggregate. Mila hua hai gases. It's not that the gases have reacted chemically. Otherwise, if I have hydrogen, if I have oxygen, they react and they give me maybe water. Aisa nahi hai. Okay, we have water. Otherwise, hydrogen can remain separate and this can remain separate. So they are a mixture. They are a mixture. They are a physical aggregate. In physical aggregates, the constituent matter will retain their properties. In fact, I'm sure in school, most of us have remembered reading that we can separate oxygen from the atmosphere. We can separate hydrogen from atmosphere. We can separate carbon from atmosphere. Why? Because they are mixed. They're not chemically entirely, fusing in terms of chemical reactions. No. So the atmosphere is a mixture. The third point here is, now see, although I'm saying the atmosphere is not homogeneous, but for much of the atmosphere's mass, the atmosphere is fairly well mixed. For much of atmosphere's mass, the atmosphere is fairly well mixed, such that it acts like a unified gas. It acts like a unified gas. Okay, what I mean by this sentence, physical aggregate means a mixture. A compilation is a mixture, aggregate. Things have come together. Now, what I mean by this is, for example, there are 100 molecules of atmospheric gases. And the 100 molecules include maybe carbon dioxide, maybe water vapor, maybe nitrogen, maybe argon, sab mila ke 100 hai. And for about, okay, say 90 amount of atmosphere. So 90 of them, if we take 90 of them here, and there are 10 of them here. These 90, the whole atmosphere are not well mixed, but the 90 is very well mixed. Okay, such that the whole thing acts like one body. So it's like I pick up an air packet here. This air behaves like one entity of gas, although it has separate gas inside this. Okay, so this is one of the behaviors of our atmosphere. The atmosphere is a mixture, but for much of its mass, it is so well mixed that it behaves like a unified gas that obeys the laws of gas properties. If you know about Charles' laws, Gay-Lussac law, Boyle's law, yes, Avogadro's number, kuch laws hain. The gas behaves like one single gas. The air behaves like one single gas and obeys the gas laws of our physical earth. So unified gas hai, but single gas nahi hai. So that's an important property. The fourth important aspect is that the atmosphere has a constancy in the atmosphere. Down, please. The atmosphere has a constancy in the relative proportion of the gases composition. The atmosphere has a constancy in the relative proportion of gaseous composition, irrespective of the amount of the atmosphere. It has a constancy in a relative proportion of gases composition, irrespective of the amount of the atmosphere. What I mean by this is, say the atmosphere is the Earth's surface here. This atmosphere. Now this atmosphere, the gases are not evenly distributed. Maybe in this part, I have got 100 molecules of gas. In this part, I have only 10 molecules of gas. I go further up, maybe I have only say 1 molecule of gas. So the amount of atmosphere varies with height. But whether here or here, the gas ratio means nitrogen is 78%, oxygen is 21%, you have carbon dioxide is 0.03%, and you have argon as 0.9%. This ratio remains same. If 100 molecules, nitrogen will be 78 molecules, oxygen will be 21 molecules. If 10 molecules, then nitrogen will be 7.8 molecules, oxygen will be 2.1 molecules. If 1 molecule here, then nitrogen is 0.78 molecules and oxygen is 0.21 molecules. The ratio remains same. That is one of the very interesting properties of our atmosphere. That while the masses can vary, while the amount of atmosphere can vary, but the relative ratio, the relative proportion of gases, that remains the same. Or aise topics mein, you will not ask why, This is property of the atmosphere. This is something you're learning. Some of you are still new, you'll not understand this, but something we simply accept. Yahan par why nahi puchna hai. This is the property. This is the why for other discussions. This becomes a kind of a law. We'll talk about this in oceanography. These are called as laws of constant proportion. Ab kahin bhi chale jao, ratio same hone wala hai for much of the atmosphere. So summarizing here, when I said atmosphere is a mixture. Number 2, I said, although it is not uniform everywhere, but for much of the atmosphere, it behaves like a unified gas. The atmosphere has constant proportion of the gases. What this also means is, important point here is that the atmosphere does not have molecular segregation in terms of okay, atomic or in terms of molecular weight. The atmosphere does not have molecular segregation in terms of atomic or in terms of molecular weight. What I mean by this is, okay, nitrogen ka weight kitna hai? 14, 28 is the weight of a nitrogen atom. What's the weight of oxygen? 16, 32 is the weight of oxygen. What's the weight of water? Is 16 plus 2, 18 is the weight of water, correct? Okay. I'm assuming you know some of this, at least know it now. Nitrogen is 14 into 2, 16 into 2. Weight of carbon dioxide, it is what, 12? Okay, plus 32, that is 44, the weight of carbon dioxide. If there was molecular weight segregation, तब क्या होता? अगर surface है, then the lower layer of atmosphere should have had only carbon dioxide, because heaviest. The next layer should have only oxygen. Next heavy, इसके ऊपर होना चाहिए था nitrogen, and then you'll have probably some other gas. We don't have like this. Our atmosphere does not have layering in terms of molecular weight. Okay, uska alag reasons hai why we have layering. The molecules do not separate out in terms of molecular weight. They don't separate out in terms of the atomic weight. Okay, ये सारा mix है. So if I take up 1 unit of air here, इसमें 78% nitrogen, 21% oxygen, and the rest. Take up 1 packet of air here. यहाँ पर भी 78% nitrogen, 21% oxygen, and the rest. The mixing is very good here. The proportions are maintained. I hope you got the point here. These are the 4-5 keywords. Atmosphere is a mixture. Atmosphere is unified. Atmosphere, there is no molecular segregation. And the atmosphere has constant proportion of its constituent gases. Any doubts, anybody? Any questions? Are you all? No, all nahi. It will be too much. Are most of you maintaining pace with me? Raise your hand, not maintaining pace. Ab sharam aa rahi hai. Not giving pace? Fine. Okay. Online, some of you there? Most of you are yes. The no ones have left the class. Jao sir. Jao aap tel lane jao, maine apna padhai karna hai. See, you know, yes, Karan. Some things will grow in, don't worry. Okay, I'll try to make it slower. Okay, but then I have to maintain a pace. And remember one more thing. This examination is a competition, okay? If somebody can run fast, you have to learn to run fast. Hoga nahi overnight, but ek hafte 10 din you learn. It's not about writing fast, it's about keeping track of the key words I'm saying here. Okay, Zainab, theek hai. Zainab, I think Aryan, some of you had an issue. When I'm slow, they say we are lagging. हाँ तो बच्चों को सोचने का टाइम ही नहीं देना है. अगर टाइम दिया सोच, then you say ना lagging. If I don't allow you anything, तो मर पड़ के लिखोगे आप, कहाँ जाओगे आप? Okay, you'll all get used, don't worry. Anybody missing any point? Tell me now. I can repeat it if you want me to. Any doubts in the, till here? Any doubts? I have not entered climatology. It's all okay. You know, जो आपने conduct काटा था school में. Okay, I'm revising that. It's not even optional geography right now. Explain mixture. क्या explain करें बताओ? Mixture is one type of a mixture. Okay, a mixture has lot of things mixed inside it, and there's no chemical reactions to it. Mixture is an aggregate. Mixture means it's a collection. In collection where things are together, but there's no chemical reactions. Explain point 2. ये point 2 बड़ा गंदा है यार. What was point 2? Atmosphere is a mixture. So you have to go back to what is a mixture and what is a compound. बड़े इतने पैसे नहीं दिए तूने कि ये सब भी पढ़ाऊं बैठ के. So mixture is a physical addition. It is a physical collection. Okay, yes, so you can separate them, you can reverse them. The properties are maintained, the properties don't change. Compound, okay, there is some kind of chemical integration. As I said, now you have got oxygen, you have got a hydrogen. Okay, if you keep them together and you can separate them, we call that as a mixture. If you keep them together and they become water, okay, then you can't separate them using your regular methods. Okay. Nikita says that school life karma. Yes, yes, karma comes back to you. And if it gets worse, the karma will force you to teach things you had not studied. Ask me, I will tell you. The ultimate karma. समझ नहीं आया, but अब रट्टा मारो. Okay. Beyond a point, we say memorize. Okay. In time, you'll grow up. Okay. Now you memorize. Atmosphere is not completely uniform. Okay. Wait for those topics, Deepanshu. Wait. I'll come back and discuss on detail. Okay. Let's move on. So now, having said that, the atmosphere. Okay. Now back again. Atmosphere का जो structure है, the atmosphere's arrangement. Okay, we can study in 3 ways. I set some base limit in terms of what atmosphere is. Now we're discussing the 3 ways how atmosphere is arranged. It's something like, in a class, I can arrange the class in different ways. The same class, I'll say segregate in terms of maybe the language you speak. Segregate yourself in terms of maybe your education background. Segregate yourself in terms of your gender, maybe in terms of your priorities and your hobbies. So atmosphere can be arranged in different ways, or we can study arrangement in different ways. One is we study arrangement in terms of the physical, okay, density layering. Physical density layering is one way of studying how the atmosphere is arranged. The second is we can study in terms of physical mixing of the atmosphere. The atmosphere kaisa mixed hai. Okay, and third is we can study layers in terms of the temperature. What layer has what type of temperature trends or temperature behavior. So atmospheric structuring, atmospheric layering can be studied in 3 ways. One in terms of physical density layering. Okay, in terms of mixing of the atmosphere, kaisa mixed hai, and in terms of temperature trends inside the atmospheric layers. Okay, fine. Okay, one by one. This is say 1, this is 2, this is 3. Okay, the first one in terms of density, layering. Okay, the atmosphere has variations in density. Okay, now isme a very important point is the density layering. The density layering is not in terms of the molecular or the atomic weight. This part is clear to all of you? It's not that the heavy gases are below and the light gases are above. Aisa nahi hai. Atmosphere is layered, but layering is not in terms of molecular and atmospheric weight. Ye nahi hai. So what do we have? Okay, you all know, right? The lower layers of atmosphere has more air. As we go up, we have got less air. You go up the heights, you have breathing problems because we have got less oxygen. Your nose can start bleeding because the pressure is less. You come down, you have got more pressure. I hope you all know this point, right? Why does that happen? So atmosphere has density layering. Now anybody can tell me why? We do not have molecular weight layering, but we have density layering. Why? So what we have essentially is, agar surface hai, in the lower layers, I probably have 1000 molecules. You go above, maybe we have got 100 molecules. You go above, maybe you have got 10 molecules. The density reduces with height. But in every layer, we have the same ratio of gases. In every layer, same ratio of gases. Anybody can tell me why this happens? Why do we have this layering? Gravity. Okay, what else? If gravity is the only factor, तो आप सीधा बता सकते हो ना, atmosphere molecules can segregate out. Gravity is a fact. I'm not saying not wrong. It's right. But if I say gravity, then I can always say कि we can have molecular segregation, right? The heavier gases are below, light ones are above. Because of temperature, because of, yes, Ashish, you are there, something, insulation. Oh, no, I think you're getting more creative. Huh? Convection. I'll take over. Okay. Now listen, because of two factors. One is air has weight. If air has weight, okay, it's pulled down, and air is compressible. That's a more important factor. Because see, if at the lower layers, if I'm here, this air has the weight of the entire thing here. So this weight will compress this one. You go up, less air. This will compress, but less. But it will compress hoga. You go above, again less air. So what happens is, the layering is because you have got more air here. Okay. You go up, the air becomes rarefied. You go up, the air becomes even more rarefied. Because air has weight, and this weight can compress the air. So this air is more compressed, and this air is probably less compressed. It's more expensive here. So why do we have density layering? Is because air has weight plus air is compressible. That's why the lower layers of atmosphere has more molecules. It has more density. It reduces as you rise up with height. When you all had your chance to answer, but okay, you go by my answer. Piyush, I know you are requesting repeatedly. Not now. We have done it already. Maybe in some other context. Not now. Okay. All good, all of you? Air has weight and air is compressible. Because of this, if you draw a graph, अगर ये graph है, so this is the height and this is the pressure of atmosphere. Okay. And pressure I'm measuring in terms of 1 atmosphere. Means the weight of entire atmosphere. Okay. So if the 100 molecules, pura atmosphere has 100 molecules, the whole weight is 1 atmosphere. Okay. Half molecules is half atmosphere. 1 atmosphere is equal to 76 centimeters of mercury column. I hope you know this. That's approximately equal to, I think it's 1032 millibars at the sea level. This is the level 0. Okay, this is the sea level. Okay, so at the sea level, the pressure is 1 atmosphere. If you rise up by 5.6 kilometers, the pressure is half. What's the meaning of half? Ka matlab kya hai? Half atmosphere is over within 5.6 kilometers. Agar pure atmosphere mein there are 100 molecules, 50 molecules are within 5.6. Okay. It now becomes, okay, just 10% left at height of 16 kilometers. 1 atmosphere, a half atmosphere. Okay, this is 0.1 atmosphere. Okay, so look at how it rapidly reduces in terms of pressure. Okay, but 16 kilometers tak, the atmosphere 90. So if 100 molecules, 90 molecules are within 16. I hope you got the point here. So no, not 0.1, it's 1, sorry. It is 1 atmosphere. This is 0.5. No. Yeah, 0.1. 0.5, 0.1. Right. And by the time you come towards approximately 28-30 kilometers, almost 0.99% of atmosphere is over. 100 molecules hain, 99 are within about 30 kilometers. Anybody knows the height of atmosphere? Kahan tak atmosphere hai? Kuch bhi number mat bolo. Okay. Oh, vitamin, protein, you are still there. Hi. I thought you would have become nuts and bolts by today. What's the height of atmosphere? What's the height of atmosphere? Approximately, we consider around 800 to 1000 kilometer is the height of the atmosphere. Atmosphere slowly, gradually merges with outer space. Yes, right, Charu, correct. No, Keshav, you have been a bit more generous. Utna nahi hai. Okay, so some books will write 800, some, and it's a standard we accept. Otherwise, there's no boundary as such. That one extra zero matters a lot. Okay. Okay, so 1 million can become 10 million. Okay. Okay. So imagine the atmosphere exists up to 800 kilometer, and I'm saying 99% is over within 30 kilometers. So यहाँ पर क्या ही बचता है? Okay, the atmosphere is therefore I'm saying not homogeneous in terms of the entire spread. There are variations, the density, okay, stratifications of the atmosphere. All good? Okay, so remember this graph, okay? 1 atmosphere, it becomes a half atmosphere, 5.6 kilometers above sea level. It becomes 0.1 at around 16 kilometers. If the atmosphere is 1000 kilometers, hardly anything left in the upper heights. So yes, atmosphere is layered in terms of density like this. All good? Okay, fine. Next point. So we have done the first one. The density layering we have done. Now come towards mixing of atmosphere. Come towards mixing. Number 2, relative mixing of atmosphere. Now, the atmosphere is largely well mixed. It is largely well mixed for much of its mass. Okay, the relative proportion of the gases is maintained. The atmosphere is well mixed for much of its mass. For much of its mass, the relative proportion of gases is well maintained. Ratio बताया था आपको मैंने. Nitrogen is 78, oxygen is 21, okay, CO2 is 0.03. That ratio is almost maintained. However, the lower 80 kilometers is better mixed. The lower 80 kilometers is better mixed, and this layer is called as the homosphere. It's called as the homosphere. The above layers have molecular, have atomic, and have ionic weight segregation. An exception that we have. The lower 80 kilometers is very well mixed. It's called as the homosphere. Beyond 80 kilometers, there is some amount of molecular segregation. There is some amount of atomic segregation. We have ionic segregations. Ions, they separate out. And we call the above layers, above 80, we call this as the heterosphere. It's called as the heterosphere. So I can divide the atmosphere into the lower layers. We call this as the homosphere, because here the mixing is much better. Okay, and this above layer is called as the heterosphere. In the heterosphere, the ions and molecules separate out. The lower layer is nitrogen, Okay, इसके ऊपर में we have got oxygen, इसके ऊपर में we have got helium, इसके ऊपर we have hydrogen. Okay, hydrogen ions होते हैं, oxygen ions हैं, nitrogen molecule, and helium also is like a molecule. That's how the layers are in the upper layers. The lower layer is nitrogen, उसके बाद oxygen, okay, 2 minus, ionic oxygen, then helium, and then we have got hydrogen. Okay, so the generic statement I made, that atmosphere is very well mixed, right? But not in the layers above 80. But then you know, no, 99% of atmosphere over by 30-40 kilometers, right? So यहाँ पर कुछ बचता ही नहीं है for that matter. The heterosphere has much of the ions of the atmosphere. It has much of the ions of the atmosphere. You also call these layers as the ionosphere. It's also called as the ionosphere layers of the atmosphere. Yes, I'll come to that. Charu, you're right, Charu, correct. Ravikant, पढ़ाई हो रही है? Okay, keep making your notes. Okay. Like I said, yes, Pratham, correct. All these topics are important for your GS. Okay, in fact, these topics are more important in GS than in optional. Optional में इसके questions पूछते नहीं है, but I cannot move ahead without telling you all of this. Somebody has raised your hand. Okay, इतना polite आदत नहीं है यार, बोल दो जो बोलना है. So polite. Okay, मैंने. What's your point? What's your question? Anand, you have raised your hand. No, you also have hydrogen elsewhere also, but very, very less. It's almost like insignificant. Anand. But you're right, much of it is in the upper atmosphere, correct. Ionosphere, the whole layer is called ionosphere. The entire thing is called the ionosphere. Usme there are some segregations. Okay. Okay, Anand. First point under mixing. Yeah, first point under mixing, kya point tha? Okay, or maybe I wrote it here itself. But kya point tha, bata do? Atmosphere is? It's largely well mixed. What doubt you have? Or repeat it. Vedehi. Okay. So atmosphere is largely well mixed. See, Sonal, these two words mean different. Heterosphere is, okay, I'm answering. He's asking me, sir, is heterosphere also called as ionosphere? Now look at this. When I use the word heterosphere, I mean the degree of mixing. When I use the word ionosphere, I mean the composition. Okay, so they're not same actually in terms of what they mean. Maybe they coincide for same layer, but they mean two different things. Like I as a teacher, I'm not same as I as my hobby traveling. Ye do alag cheez hai. Okay, so when I say heterosphere, I'm talking about atmosphere in terms of the mixing tendency. And when I say ionosphere, I'm talking about what is it made up of. So don't use the terms as synonyms. They mean two different things. If there's no molecular segregation lower layer, it defies law of gravity collapse. Bus. Okay. I'm sorry. Okay. What defy, non-defy will enter into quantum physics. Okay. And let Oppenheimer do that. Okay. I will leave it here. Shikha, क्या समझ में नहीं आया? बताओ. Show the slide of the previous graph one by one. Tochan, you want the graph? So, graph तो गए हो यार. मैंने दोबारा बना देना है. Oh, not this one. The graph of proportion versus the pressure. So this is the sea level. This is 1 atmosphere. This is 2 atmosphere. This is 3 atmosphere, and so on. This is 0.5 atmosphere. Okay. So at the sea level, it is 1 atmosphere. You rise to 5.6 kilometers, it now becomes half atmosphere. You rise to 16 kilometers, it becomes 0.1 atmosphere. You rise to 28, 30 kilometers, it becomes 0.01. So the pressure starts reducing like this. Okay, this is a half atmosphere. Okay, here you have 0.1 atmosphere. This is 50% is gone, and this is 90% gone. And you hit beyond this, 99% is gone. Yes, approximately around 30 kilometers. Graph is clear, Shikha? Okay. बोलते हैं दोबारा बनाओ sir. Okay. You like my drawing, so I'm making it. 0 as in sea level. And what does 1 atmosphere mean? In terms of the weight of the entire atmosphere is 1 atmosphere. So my head is taking the weight of 1 atmosphere if I'm at the sea level. And you can, ये अलग-अलग units हैं. In terms of barometer height, in terms of millibars, different values we have. Yeah. Akshay, tell me, what's the question? Offline, any doubts here? Any questions? Any clarification? Raise your hand. Yeah, any questions? So I think the leakage of information in transmission, I think. Offline, mein, okay, it happens more effectively. It goes through the connectivity, there's leakages there. Corruption hota hai beech mein. Okay, Atle guy chupa ke rakh liya, ye part main dunga nahi. Okay, rest can pass life. Any doubts offline? Okay, let's move on. ये कहां से आ गया दीपांशु? लॉरेंस कर्व में क्यों जा रहे हो? ऐसे छेड़ो गया तो मैंने और 5 नाम बता देना है. मुझे पता हो नहीं पता, मैं बोल दूंगा ग्राफ का नाम. Okay, come back. So I'm done with 2 aspects of atmospheric layering. The third one, this is more important. Okay, the temperature trend based structuring of atmosphere. The temperature trends based structuring or layering of the atmosphere. So in different layers of atmosphere, what is the pattern of temperature? That's what we are discussing. What's the pattern of temperature? Now, a couple of points here. 1, 2, 3, 4 points. The first point is, okay, the fundamental source of all energy for the planet and for the atmosphere is the solar energy. The fundamental source of energy for the planet and for the atmosphere is the solar energy. Okay, so solar energy is also referred to as insolation. It's also called as insolation, short form of incoming, okay, solar radiation. Short form is insolation. Whatever comes in is insolation. And remember, I'm talking about radiation. Okay, I'm talking about energy that's coming in the form of a radiation. So when energy comes in radiation form, there are different wavelengths in which they come in. So we have gamma rays, we have X-rays, we have ultraviolet rays, we have the visible spectrum, we have the infrared, we have microwaves, and we have radio waves. These are the range of the wavelength that come into Earth. Okay, gamma rays, X-ray, ultraviolet. This is the visible spectrum, if you know about the Vibgyor. Okay, infrared, microwaves, and radio waves. Okay, now in these waves, the gamma rays and X-rays are very high energy waves, the very powerful ones. Okay, very powerful ones. The microwaves and radio waves are less powerful. In terms of wavelength, this has the shortest wavelength, and this has the longest wavelength. And remember this, something a short wavelength will be very powerful ones. Okay, and something which has long wavelength is not as powerful. So coming from the sun, okay, microwaves, radio waves are almost zero. Okay, hota hi nahi hai. Why? Because utna energy nahi hai to reach the earth. So if this is the sun and this is the earth here, and energy coming in to earth. Okay, so so your radio waves and microwaves, they die off beech mein hi, khatam ho jate hain. Then there are gamma rays and X-rays. Okay, now gamma rays, X-rays are a very large amount of Earth's sun's energy. But what happens is, much of the gamma X-rays, its source is the core of the sun. There is this fusion reaction going on. Okay, and from here the gamma rays are coming, X is coming. Much of it does not escape the sun's surface. वो अंदर ही रह जाता है. Okay, why? Because some mechanism is there. Then there are a lot of loose electrons here. The plasma layers of sun hai. This can also absorb gamma rays and X-rays. And a very little amount remains. That little amount is blocked by Earth's magnetosphere. So these gamma rays, X-rays, they are absorbed here and they get deflected like this. They get absorbed partly here and they get deflected like this. So gamma rays and X-rays, agar Earth ye hai and this atmosphere here, they don't enter the Earth's atmosphere. Okay, so if you look at the electric spectrum, the gamma rays, X-rays are very negligible coming from the sun. Okay, and whatever can come, the magnetosphere can block it and deflect it. तो इसकी हम बात ही नहीं करेंगे. Microwaves and radio waves, this also doesn't come near the atmosphere of the Earth. What we're left with is these three radiations. Ultraviolet radiations. In these three, tell me which is the maximum coming into Earth atmosphere. Of these three, okay, coming into Earth atmosphere is how much? So there are two things here. Is the Earth here? The Earth atmosphere here. So some comes here and some comes still here. Okay. So entering the Earth's atmosphere, the maximum is ultraviolet. Ultraviolet almost, I think it is about 54% of all energy into Earth atmosphere. The visible spectrum, approximately 45 and 47%. NIR is less. The remaining. It's about 4% or 3% or 4 to 7% is IR. Okay? Coming into Earth atmosphere. But remember, by the time they hit the surface, ultraviolet is gone. What comes inside is maximum is the visible spectrum. Okay? Remember some of the data here. Okay? I repeat, the energy coming into the Earth from the sun, it's a range of energy. So I remember this mnemonic as Gaksu Vimar. Okay? Some mnemonics we'll use. It works for me. Okay, gamma rays, X-rays, ultraviolet, visible spectrum, infrared, microwave, radio waves. These two are almost zero. This much absorbed by the sun itself, and whatever remains, the magnetosphere is deflecting and absorbing it. What enters atmosphere are these three: ultraviolet, visible, and infrared. So write down, please. Write down this point, that the solar radiations are entire range of electromagnetic spectrum. Write down, please. The solar radiations are the entire range of electromagnetic spectrum. Okay, and write down this. Okay, 1, 2, 3, 4. Gamma rays, X-rays, ultraviolet, visible. V is visible spectrum. What we can see, infrared, microwaves, and radio waves. Achhi baat hai, otherwise write it down. Then I am saying the gamma rays and X-rays are largely absorbed by the sun itself and its plasma outer layer. The gamma rays and X-rays are largely absorbed by the sun itself and its plasma layers. Beyond the sun, there are some layers called as plasma layers. They have some electrons in that. They can absorb it. So gamma rays, X-rays, wahan ho gaye. Okay, and a negligible amount of gamma X-rays, is also absorbed and deflected by Earth's magnetosphere. It is absorbed and deflected by Earth's magnetosphere. But remember, though I'm saying it's negligible, and that amount, agar Earth ke andar aa gaya, Earth will get roasted. Okay. In fact, we have found this correlationship. There are moments in Earth's history when Earth's magnetic field had disappeared. It had become zero. And those moments, okay, we also have high extinction rates. So that energy must have come inside and literally boiled the Earth itself. And then the field is formed again. Again, the gamma rays, X-rays are blocked. These are very, very harmful. You can't survive this. If this starts happening, okay, you are done. Okay, so this doesn't come in, thankfully. Then microwaves and radio waves. Microwaves and radio waves are lost in the outer space. They are not powerful enough. They're lost in the outer space. The microwaves and the radio waves are not powerful enough, and they're lost in the outer space. They're long wave radiations. They can't come into the Earth. Okay. Next slide down. The Earth's atmosphere receives. Therefore, the Earth's atmosphere receives. Yes, Avinash, correct. It receives ultraviolet. I said approximately 53-54% is ultraviolet. Receives visible spectrum of energy around 43-44%. And infrared 3 to 7%. I mean, don't add up and say 100 nahi hua. Okay. That's the approximation that we have. They enter the atmosphere. Okay? Okay, next slide now. Next slide down. The ultraviolet layers, the ultraviolet radiations are partly absorbed in the outer ionosphere. They are partly absorbed in the outer ionosphere and in the ozone layers of stratosphere. जो ultraviolet है, they are largely absorbed. Absorbed where? In the outer layers of the atmosphere, which is the ionosphere में absorb होता है, plus also absorbed in the ozone of the stratosphere. This layer में it gets absorbed. This ozone is approximately in the range of 15 to 30 kilometers के height में है from the surface. Okay, ozone layers. Okay, so it is absorbed, which means ultraviolet radiations do not reach the lower layers and Earth's surface. Lower layers of atmosphere and the Earth's surface. The ultraviolet radiations, they do not reach the lower layers of the atmosphere and the Earth's surface. That's one point. Then we have the visible spectrum. This is 53%. ये खत्म हो गया. Then the visible spectrum, what we can see. Who absorbs this one? Or what absorbs this? Anybody? Visible spectrum is absorbed by which layer of atmosphere? This spectrum, this range is approximately 0.4 microns to 0.7 microns का range है. Microns in terms of wavelength, the unit of length. 0.4, 0.7 micron is called as the visible spectrum. So which layer of atmosphere absorbs the visible spectrum? Anybody? Okay. Atmosphere is not capable of absorbing the visible spectrum at all. The visible spectrum jo hai, the atmosphere is transparent to visible spectrum, which means it passes through the atmosphere and hits the Earth's surface. It passes through the atmosphere and hits the Earth's surface. So imagine this. Say this is the outer layers of atmosphere. This is the stratosphere. And there's some lower layer here. There's some lower layer here. And then we have the surface of the earth, the land, the oceans, and the rocks. Okay. These layers, ultraviolet is getting absorbed. These layers, ultraviolet gets absorbed. Okay. So yahan par there's no ultraviolet. And then we have infrared. Okay. Thoda bahut yahan hai, thoda bahut yahan hai, not much here. And वैसे भी infrared is just about 0.57%. Then we have visible spectrum. Visible spectrum, this can't stop. Visible spectrum, this can't stop. And even this can't stop. It comes and hits the earth directly. The visible spectrum means the visible spectrum is not heating any layer. An atmosphere ka heating jab hi hoga na, when the layer absorbs that heat. It's like I am standing. The energy goes right through me. The energy will not heat my body. Only when my body absorbs it, that I will start feeling the heat. So the upper layer is heated by what? The ultraviolet. This layer by what? Ultraviolet. What is heating here? Okay, यहाँ पर ultraviolet भी नहीं है. यहाँ पर infrared is not of much significance, and even visible has no role to play. So this layer is one layer where the incoming radiations have no impact. Okay. This layer is not heated by the energy coming from the sun directly. Head down. This implies the lower layers of the atmosphere. The lower layers of the atmosphere are not heated by the lower layers of atmosphere are not heated by the insolation from the sun. They are not heated by the insolation from the sun. Okay. See, if some things we know, but you realize this differently. Imagine here, this is the surface, and this is the mountain, and you are here. If this layer is heated from the sun, then this part must be hottest and this part must be coolest, correct? ऐसा नहीं होता है ना? Okay, you actually feel cold here, which means the energy coming in is not heating you at all. What heats you is this energy comes, strikes the earth, and when energy goes back, it starts heating the earth. That's why the layers surface ke paas mein, these becomes the hottest. A bit away, this becomes less hot. A bit away, this is very, very cold. So in the lower layers, the heating is not from top towards bottom. It is from bottom towards top. The atmosphere is heated from below, not from the top in the lower layers. Okay, this implies in the lower layers, atmosphere is not heated from the top. In the lower layers, the atmosphere is not heated from the top. The insolation gets absorbed at the Earth's surface. The insolation gets absorbed at the Earth's surface, and it is re-radiation from the Earth's surface. It is re-radiation from the Earth's surface and other forms of energy loss. It is re-radiation from the Earth's surface and other forms of energy loss that heats the atmosphere from below. That heats the atmosphere from below. And remember this point, put a star mark here. The incoming radiations are shortwave radiations. The incoming radiations are short-wave radiations. का मतलब क्या है? The very powerful ones. Okay, very powerful ones. Okay, what can absorb them? The incoming radiations are very powerful. They're short-wave. What can absorb them? Ultraviolet is absorbed by ozone and ions. For the incoming radiations, carbon dioxide has no role to play. Water vapor has no role to play. Okay, no role to play by dust particles or other aerosols. So the incoming radiations, they can pass through all the gases. Ozone can trap ultraviolet. The outgoing radiations, which are less powerful, they are long wave radiations. The outgoing radiations, water vapor can trap. The outgoing radiations is carbon dioxide trapping, carbon monoxide trapping. The dust particles are trapping. And the pollutants like methane are trapping. And that's how the lower layer becomes warm. You rise up, it becomes relatively cooler. Head down. Okay, so मैंने कहा कि the incoming radiations are shortwave radiations. Okay, and the atmosphere is largely incapable of intercepting it. The atmosphere is largely incapable of intercepting it except for ozone absorbing ultraviolet radiations. Except for ozone absorbing ultraviolet radiations. ठीक है? Next point. The outgoing radiations, we also call them as terrestrial radiations. The outgoing radiations, they are the terrestrial radiations. They are long wave radiations. They are low energy radiations. Okay, the outgoing ones, they are long wave, the low energy radiations are effectively absorbed by greenhouse gases like carbon dioxide, water vapor, pollutants like monoxide or dust particles, etc. Okay? So it's like what comes in doesn't warm, what goes out is warming. Therefore, the atmosphere is heated from below. The atmosphere is heated from below. I think most of us know these points, but maybe not in as much detail probably. Okay, or if not, fine, you learned it now. So if I have atmosphere, surface of the earth, these are the layers of atmosphere. Okay, the above layers, it is heated from above. Some layers heated from above. From above, ultraviolet does it. From above, ultraviolet does it. And some layers, they are heated from below. Heated from below. And this is the terrestrial radiation swarming. So this pattern gives us a temperature trends in the atmosphere. Is it okay, all of you? Any questions on this? Yes, Akul, clouds absorb outgoing ones more efficiently. Clouds can block and reflect the incoming ones. Okay, so keep it like outgoing radiation, because clouds be lower layers mein hi hote hain. Head down. This right next. This mechanism of atmospheric warming. This mechanism of atmospheric warming creates temperature trend layers in the atmosphere. It creates temperature trends layer in the atmosphere. Any questions here? By the way, before I forget, all the older students, geomorphology, next week you have your recall sessions and your practice workbook also. I think it's from Monday we have a synopsis recall test, and Tuesday we have your workbook test. Then we'll enter into previous year's question discussions. So only for those, the older ones. Okay, I was supposed to announce this earlier, I forgot. Next week, Monday, Wednesday, I think we have put the dates. Climatology students, be with me. We'll do it afterwards when the unit gets over. Okay, all done on this? Fine. So now what we have is, so based on the temperature trends, the atmosphere has 4 layers. Based on temperature trends, the atmosphere has 4 layers. 4 layers kya hai? Okay. Now you know the names more or less. We have the lower layer called as the troposphere. Then we have stratosphere, a transition layer called as mesosphere, and then we have thermosphere. This is the troposphere. This is the stratosphere. Okay, so for some of you not initiated, the troposphere, the stratosphere, the transition layer called as mesosphere, and we have thermosphere. The stratosphere is about 50 kilometers, mesosphere up to about 80 kilometers. And then, of course, go at 100 or 800 or 1000, whatever. ठीक है, लिख लो Madhav. I didn't add anything else here. These are the 4 layers of the atmosphere on the basis of temperature trends. On the basis of temperature trends, the troposphere, stratosphere, mesosphere, and thermosphere. Okay, so troposphere, this is heated from below. Okay, so it is cooling with height. The troposphere, keep writing please. Troposphere kaisa hai? Troposphere is heated from below. So what heats the troposphere is the outgoing radiations, the terrestrial radiations. When they're going out, they will heat the troposphere. Okay, so it cools with height. The lower layers are warmer, the above layers are more cooler. Okay, the stratosphere, energy comes in and they start absorbing heat incoming. So stratosphere is heated from above. So the above layers are warm, the lower layers are cold. Isme the lower layers are warm, the above layers are cold. The thermosphere. The thermosphere, it has ions. So this also is heated from above. Means the warm layers are above and the cool layers are below. All done? Okay. So this thing we show in terms of graph. So that is the troposphere, the stratosphere, the mesosphere, and thermosphere. The graph is, okay, if this is the say ground level, and say this has the temperature and height, what we show is with height बढ़ रहा है, the temperatures will fall. It becomes cooler, so it becomes cooler. Forget the values here. Okay, अगर warm है ज़्यादा, it will start cooling. The stratosphere is warm above, it starts cooling as you come down. इधर आएगा तो it's cooling. On this side, we have a temperature reducing. On this side, we have temperature increasing. And on this side, I am plotting the height. Okay, so temperature falling like this. Thermosphere, again, the above layers are warm. Okay, and it will cool like this. This is warm layer. This is the cool layer. This is the warm layer. This is the cool layer. This is the warm layer. This is the cooler layer. Troposphere heated from below. Stratosphere heated from above. Okay. Why? Because the ultraviolet absorbed by ozone. Isme the ultraviolet absorbed by the ions. Okay. In this, the terrestrial long wave absorbed by carbon dioxide, water vapor. We have got the pollutants. Okay, we have methane and all of that. So mesosphere, बीच में आपकी line जोड़ दो आप. Which means mesosphere is again warmed from below. This is warm. Okay, you rise up, it becomes cold. This is a transition layer. All good? All fine, all of you? Yeah, values hain, like at the mesosphere, here the temperatures can reach almost -90 centigrade. It becomes very, very cold in parts of mesosphere. Forget about those values for now. So the four layers are based on the temperature trends. Okay, this is a reducing temperature, increasing temperature, again reducing, and again increasing. So this line represents the trend of the temperature. And this trends has some value also. Okay. So for the troposphere, the rate of cooling with a height is called as what? It's called as normal lapse rate, NLR. कितना वैल्यू है? 6.4 centigrade per kilometer. For the troposphere. So they're all values, but forget about the rest. This one I'm discussing. For the troposphere, is falling temperature. इसका एक pattern है. The pattern is the normal lapse rate or NLR, which is 6.4 centigrade per kilometer. My question to you is, the 6.4 is what value? Is the maximum value, minimum value, average value, median value? What is it? Yes. It is what value? Average. बेटा इतना आसान अगर होता मैं पूछता नहीं, right? Optimum value, whatever that means. What value is this one? Minimum value. Okay, I trapped you. Okay, fine. Okay, I succeeded. This value is a hypothetical value. ये reality में नहीं है. कितना धोखा होता है बताओ तुम्हारे साथ में? It's a hypothetical. It's an imaginary value, assuming that Earth is in steady state of balance. It's a hypothetical value for the steady state Earth. ऐसा अगर condition है where Earth is perfectly in balance, energy coming in, going out, perfectly match हो गया. At that time we say this is the value. In reality, Earth is not in balance. Earth is trying to balance. That's why we have ice age, warming, again ice age, again warming. Okay. So if Earth was in balance, if Earth is in steady state, then we say this would have been the value. Okay. It's a hypothetical value. It's an imaginary value. Okay. Agar Earth was having no disruptions, if Earth was in balance, then the troposphere would cool at this rate. Okay, all of you fine here? So in reality, then what do we have? If this is NLR, hypothetical hai, okay, which is not the reality, then in reality, what do we have? In reality, we have environmental lapse rate. This is called as the ELR. In reality, we have the environmental lapse rate, also called as ELR. So NLR is 6.4. ELR ka value kitna hai? What's the value of ELR? ELR is not a constant number. It varies from place to place, seasons, type of surface. It depends on daytime, nighttime. Okay, so ELR is not a constant number. It's a variable, okay, number. It depends on seasons, daytime, nighttime cycles. It depends on the type of surface, land hai, water hai, ice hai. It depends on the composition of atmosphere. Whether do we have more dust particles there? Do we have more water vapor there? It's a variable thing. ELR is a variable number. Is it okay, all of you? So one question I will add and see if you understand this point here. Dekho, this is the Earth's surface. This is the upper height of troposphere, correct? And this is far. It's about 6-7 kilometers above the Earth's surface. So can you all appreciate the fact the temperatures here will not vary much? वो daytime ho, nighttime ho, okay, वो summer ho, winter ho, whether land or water or ice or snow, whatever, it's very, very far. Your aeroplanes fly at height of 36,000 feet. That's approximately about 10-11 kilometers above the Earth's surface, where things don't vary much. Whatever variations we will have it here. Here, some area will have more moisture. Some will have more dust particles. Some areas will have more pollutants. This is the land. This is the water. Upar to it's at 6 kilometers height doesn't vary much. So the lapse rate hai, this rate of cooling, environmental lapse rate cooling, will depend on what? Depend on this temperature or this temperature. Depend on top temperature or bottom temperature. I got the point, all of you? Okay. At above heights, yes, above heights, things don't change much. Bahut dur hai. Okay. So this temperature is almost fixed. Whether you are in India, you're in US, you're in the polar areas, you are in China, you are above the water, above mountains, whatever. More or less, this is not very much. This varies quite a bit. Summers they can become very hot. Winters very cold. Summers on the land even more hotter. Okay. On the ice surface, kuch aur temperature hoga. All got the point here? So now you tell me the lapse rate. The rate ka matlab kya hai? Difference of temperature. The difference of temperature is more when this is warm or this is cold. I'm asking again. Okay. I said this temperature doesn't vary much. Whatever varies is the lower layers of the atmosphere varies. Correct? Now, when I'm saying lapse rate, when I use the word rate, I'm talking in terms of some change, a difference of something with respect to time or height or whatever. Rate is some difference I'm calculating. Okay, so this is temperature A. You come to 1 kilometer, it becomes B. Come to another 1 kilometer, it becomes C. The difference is called as rate, correct? My question is, the rate will vary on what basis? Ground basis, correct? My question is, the rate is more when this is warmer or this is cooler. Got it here? When rate is more, ka matlab kya hai? The rate of cooling is more or the rate of warming is more? Lapse rate means cooling. Got it? So now, when is the lapse rate more? Summers or winters? When is the lapse rate more? Daytime or nighttime? When is the lapse rate more? Summer on the land or summer on the water? Lapse rate more. Summer on the land near the coast or summer on the land inside the interiors? Got it here? So जिस जगह का ज़्यादा temperature होगा, that area will have higher lapse rates, higher cooling rates. Got it? Okay, I'll use this afterwards, but for now remember this. So which areas will have higher lapse rate? Polar areas or tropical areas? Write this point down. That lapse rate, ELR, is not about NLR. NLR तो constant है and hypothetical है. Okay, घुमाने के लिए भूत हमें पकड़ा दिया. Okay, the NLR is of no consequence for us right now. Yes, correct. Okay, so our point here is that the environmental lapse rate, okay, is more when the surface is warmer. Environmental lapse rate is more when the surface is warmer. That is in summers. That is in summers on the land. In summers on the land. That is in summers on the land in continental positions away from the coast. In summers on the land in the continental positions. ठीक है? So ELR depends on the surface of the earth plus down here ELR. Okay. Therefore cannot be fixed for any location. It cannot be fixed for any location. I hope you appreciate now NLR kya hai, ELR kya hai. And what do I mean by NLR is more? NLR more, so ELR more means it's cooling more rapidly. Okay. And then we'll have some impact on the climate, rainfall and the rest. Okay, fine. So that was your first day for climatology. I'll preserve you to kill you some other day. Okay. Khyati. The whole of geomorphology. Yeah, Monday, Wednesday, and we'll announce the dates again. Tomorrow we continue, same time. Okay. Holiday, why holiday? Yeah? Raksha Bandhan. Are yaar. Dekho, if your sister really loves you, okay, call her to class, yahi Rakhi bandho. If you are the sister and your brother really loves you, usko yahi bula lo. और इसमें कोई नहीं है, यही बांध लो. Okay. अब आए हो तो कुछ लेके जाओ, right? Okay. So take a sister and a brother back to you with you. Rest, keep it preserved for your academy. Okay. No chutti. Bye all of you. Have a nice day.